Now let's see the case for infinitely many solutions. So for example, this question asks you to solve this system of equation using Gaussian method. Okay, so what you should do is, first step, write this in terms of augmented matrix. So this is 2, 2, 4, 1 minus 1, 2, minus 1, 5 minus 2, and make a separator like this, and then put 8, 2, 2 here. So first of all, we want to make sure the first term here is 1. So when we look here, we have 1 here. So let's just exchange row 1 and row 2. Okay, so this is very simple. Just take the whole row 1, exchange, put it at row 2, and the whole row 2, put it at row 1. Now, let's focus here. Okay, these two terms here, we want to make sure both of them are 0. So what we should do is, what should we multiply to 1? When you plus 2, you get 0. So the answer here is negative 2. Now let's look at this entry here. We want to make this 0. So what should we multiply to 1? When you plus minus 1, you get 0. So what we should put here is 1. Then we have this 2 ERO, and then let's use it to make this term 0 and this term 0. Next, let's make this term 1 here. So what we should do is, we must take 1 over 4, multiply to row 2, and then put at a new row 2. So what we get is 0, 1, 0, 1. Then let's make this part here become 0. So what should we multiply to 1? When you plus 4, you get 0. So the answer here is negative 4. So what we should do is, we must write negative 4 R2 plus R3, put at the new R3. So now we can do the calculation here to this row here. Okay, so we'll get the answer of 0, 0, 0, 0. So now let's focus here. The next step should be, we want to make this term 1. However, this term here is accidentally becomes 0. So we cannot adjust it. We just take it as it is. This is 0x plus 0y plus 0z equal to 0. So let's write here, and then let's finish up this one. This is 0 equal to 0. So now let's focus on this statement. This statement is a correct statement. 0 is equal to 0. Therefore, straight away write this as infinitely many solution. So we know when we have 0 equal to 0, this is the case of infinitely many solutions. Alright, so what is the next step we must do is, we must let z as any real number t. Okay, so let z equal to t. Then let's read the answer for y. So y is equal to 1. So that's the answer for y. And then let's read the answer for x. X minus y plus 2z equal to 2. So let us substitute the value of y and the value of z that we already know. Y is 1 and then z is t. Therefore, we'll get the value of x. X is equal to 3 minus 2t. So now we can conclude our answer. X, y, z in coordinate form is equal to 3 minus 2t, comma, 1, comma, t, and then t is any real number. If you want to take out a few coordinates here, you can do that. For example, you can let t equal to 0. Therefore, x, y, z is equal to 3, 1, 0. We can also take t is equal to 1. So your x, y, z will be equal to 3 minus 2 is 1, 1, 1. So this is the example of the case of infinitely many solution. Now let us see the case of no solution. So for example, you are given this system of equation here and you are asked to solve for Gaussian method. Alright, so what we should do is, let's open up augmented matrix. 1, 1, 1, 0, 1 minus 3, 215, and then make a separator here is equal to 210. So first of all, you must make sure the first term here is 1. So this is already 1. So nothing should be done there. Then let's use our energy to focus on the next term. We want to make the next term 0. This is already 0, so nothing should be done here. And then we want to make sure this is equal to 0. Okay, so we only need to do works for this number here. So let's write what should we multiply to 1. When you plus 2, you get 0. So the answer here will be negative 2. So let's write here negative 2 R1 plus R3 put at the new R3. So you can see the calculation here, negative 2 R1, and then this is R3, and then just add them up. Okay, so let's fill in here. So now we are finished with 100. Next term, we want to make this 1. So this is already 1. So let's focus our energy to make this number here 0. So let's write what should be multiplied to 1. When you plus minus 1, you get 0. So the answer that we need to write here is 1. So let's write it R2 plus R3 put at the new R3. So after we do the calculation, we'll get this term here. So now let us read answer. This is 0x plus 0y plus 0z equal to negative 3. So let's see the statement here. This statement shows that we are doing 0 equal to negative 3. So can 0 be equal to negative 3? No, we cannot do that. Therefore, just write 0 cannot be equal to negative 3. So since this statement is wrong, we just need to stop here and write the system as no solution.